Good evening, everyone. This is Dr. P. Polaiah, working as a professor, Institute of Aeronautical Engineering, Hyderabad. Today, our ELRV on definition and terminology on image restoration and filtering. It is one of the topic which we have to remember for understanding about how we can define a image restoration and filtering process, which is connecting with the noise models. So here, first of all, we want to concentrate on what does we mean by image restoration. Restoration attempts to reconstruct or recover an image that has been degraded by using a clear knowledge of the regarding phenomenon. Restoration attempts to reconstruct or recover an image that has been degraded by using a prior knowledge of the degradation phenomenon. So which we are going to be define restoration technique. The restoration techniques are oriented towards modeling the degradation and applying the inverse process in order to recover the original image. That is the major meaning of the image restoration. So we can extend this image restoration to understand about in detail how this image restoration consider as a technique. So that means we understand image restoration attempts to reconstruct or recover an image that has been degraded by a degradation phenomenon. As in image enhancement, the ultimate goal of restoration technique is to improve an image in some predefined sense. Like enhancement techniques, restoration techniques can be performed in the spatial domain and frequency domain. For example, noise removal is capable using spatial domain filters, whereas de-blurring is performed using frequency domain filters. And this degradation process is how can we define? How we can define degradation, the image degradation or image restoration process. So how a degradation process is modeled? Image degradation is a process that acts as an input image which is connected through one objective function. Okay, an objective function. Okay, so through a degradation function H and an additive noise eta of x comma y, it results in a degraded image is considered g of x comma y, such that g of x comma y is equal to h of x comma y star f of x comma y plus your noise model, that is additive noise, where h of x comma y is, you said, as we understand, it is nothing but degradation restoration process. Is the how we may represent also important. So where h of x comma y is the spatial representation of the degradation function, and the symbol which is star is indicates convolution. Note that we only have the degraded image which is g of x comma y. The objective of restoration is to obtain an estimate of the original image. We want the estimate to be as close as possible to the original input image. And in general, the more we know about h and eta, which are very closer, will be to f of x comma y, where f of x comma y are the objective functions. Okay, so which we are going to be defined in terms of your image restoration. Of course, so far we understand the basic fundamentals about image restoration, which is in terms of image degradation. So let we can understand that in terms of functional block diagram, which we called as image restoration and image degradation model, which we can be attained based on the your input image of the function, input function, that we are going to get your output of h of x comma y, and based on that we will get your g of x comma y is a degradation. And by applying to this degradation image to get your reconstructed original image through restoration filter, that is f cap of x comma y. What do you mean this? This is replica of f of x comma y. It is restoration of the your original image. So once you understand this image restoration by the help of restoration filter, how we may understand in detail in the sense, image restoration is the process of recovering an image that has been degraded by some knowledge of degradation function h and the additive noise term eta of x comma y. Thus, in restoration, degradation is modal and its inverse process is applied to recover the original image. That is what we understand about this block diagram. So which part is the your degradation image process is this one, the first part, and whereas second one is we concentrate restoration. Here we playing two important one. One is your input image which is you are giving, you may have certain noise. This noise may want to be minimized, so we can apply the restoration filtering process. We call as a filtering. So in detail about this discussion, we'll going to understand about some more terminology about this restoration and filtering. So what does it mean by unconstrained restoration in terms of noise? So the noise n, which is represent n, a meaningful criterion function is to seek an f such that h comma f approximates of in a least square sense by assuming the noise term is as small as possible. It is also known as least square error approach. This we are going to be understand in terms of mathematical definitions. So how we may define that? Define differentiation as sharpening is the process for form differentiation on the pixels to sharpen the image. What is the image differentiation? Image differentiation enhances the discontinuities and de-emphasizes the pixels with slow varying gray levels is the understandable about image deformation. So what are the three methods of estimating the degradation function? What are the three methods of estimating the degradation function? Number one, observation. Number two, experimentation. Number three, mathematical modeling. By the help of these three, we are going to be prepared a model which called estimating the degradation function mathematical model by the help of three methods. What is the question here? What are the three methods of estimating the degradation function? Are number one, observation, number two, experimentation, number three, mathematical model. Of course, it may be clear, but we're going to have in detail about these types, which we define three types. First of all, before we are going in detail about those three methods, we can define about the types of image degradation. Types of image degradation. So what do you mean types of image degradation? How we may be defined? So degradation comes in many forms such as motion blur, noise and camera misfocus. In case like a motion blur, it is possible to come up with an very good estimate of the actual blurring function and undo the blur to restore the original image. So that is what we have to understand from here. So you maybe go ahead by the help of to understand image restoration methods, which we may call various methods available for image restoration, such as inverse filter, Wiener filter, constrained least square filter, blind deconvolution method, etc. Some of the methods are either linear or nonlinear methods, help to remove the noise and blur from the image. So we understand the meaning of image restoration methods, which is connected in terms of image restoration of the available methods are called inverse filter, Wiener filter, constrained least square filter, blind convolution method, etc. Some of those methods are very clear based on your previous discussion about mathematical model, help us to define either linear or non-linear methods to remove the noise and blur from the original image. So image restoration is a process of covering the original image by removing the noise and the blur from the image, which is we discussed and understand the meaning of image restoration process. But image blurred, what do you mean it? How can you understand image blurred? Image blurred is difficult to avoid in many situations like photography, to remove motion blur caused by camera, that is camera shake, radar imaging, to remove the effect of image system response. Okay, so radar imaging to remove the effect of image system response. How we may concentrate in this sense? Obviously, we are going to be use this image restoration definition. Suppose if you go in detail about to understand such a image restoration. So where we call this image restoration, we understand that in terms of image degradation. Image degradation, which we extended to understand in terms of the image may have blurred, that we call the image blur, a image which have some noise, that is image noise, a image which can have blur plus noise. So based on this three approach, we may going to have to understand how these are may have the image, so that we may define by the help of noise model and its characteristics. Noise model and its characteristics. So what do you mean this noise? Noise is nothing but in digital images arises during the following. Number one, your acquired image may have some noise, or you may transmit while you are transmitting an image from one device to other may have some noise. So we may go to avoid those by using this noise and its characteristics towards to prepare a noise model. So let us to define acquisition. Acquisition means environmental conditions which we fulfilled with the light level and sensor temperature and type of cameras and our transmission, interference in transmission channel. To remove noise, we need to understand that the spatial characteristics of noise and its frequency characteristics in terms of Fourier spectrum. By the help of this process, we may going to be prepared very general noise model. That is, generally a spatial noise is assumed to be independent of position in an image and uncorrelated to the image itself. That is, there is no correlation between pixel values and the values of noise component. So frequency properties refer to the frequency content of the noise in the Fourier sense. Fourier sense. So we going to have two words to connect to the noise model. What do you mean model? Model is nothing but which help us to define that image system, as we discussed earlier. Image system behavior we are going to be concentrate. How we are concentrate image system behavior, either in terms of linear image system process or non-linear system process. What do you mean linear? Which doesn't not having any degradation. Which is no need any restoration process in terms of complex. So we may concentrate more on non-linear process. So non-linear process which we are more concentrated, then we may going to be concentrated on preparing the conversion of non-linear to linear by the help of noise filter, noise models. So the noise model which we help us towards to convert the complexity to simple process of restoration, image restoration process. So spatial noise is described by the statistical behavior of the gray level image values in the noise component of the degraded image, which is we are understanding very clearly. So noise can be modeled as a random variable with a specific probability distribution function that we call as PDF. So if you know the PDF function, it is easy to understand towards to convert non-linear to linear. That is what we have to understand about noise models. Next, if noise models which we are preparing, what are the parameters we have to consider? How we can define it? So parameters will define the spatial characteristics of noise and whether the noise is correlated with the image. Similarly, frequency properties refer to the frequency content of noise in the Fourier sense. When the Fourier spectrum of noise is constant, the noise usually called white noise. So noise models are unwanted information is in the digital image is called noise model. Noise produces undesirable effects such as artifacts, unrealistic edges, unseen lines, corners, blurred objects and disturbs background scenes. To reduce these undesirable effects, prior learning of noise models is essential for further processing of noise models in what we call the image restoration process. So we go in detail about these noise models. We have typical noise models in terms of different types of noise models. One is uniform noise model. Second one is Gaussian noise model. Third one is salt and pepper noise models. Fourth one is gamma noise model. And fifth one is relay distribution noise models, which we are going to concentrate later on for understanding each and every topic definition and its importance with some examples. Of course, you are understood so far. Some of the definitions which we covered right now are two. One is how we define restoration and restoration process based degradation image process. And also we concentrated what are the methods, how we prepare a model, mathematical model. Once we prepare such mathematical model, we depend on the component which we call noise, white noise. But how we define that noise in terms of noise and its characteristics. Of course, you understood the complete information in terms of very simple definitions. We are going to be continue these definitions in coming class also. Until up to, please refer some more textbooks to understand much more definition on the same topics, which we can refer 1 and 2 prescribed textbooks. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.